recording. Uh, I have no freaking idea when it's gonna be on YouTube because we are a little bit behind on recordings there, but we're gonna get there eventually. But that's um, that's okay. Next book, huh? Third book, Patterns of Software. Marinho, are you there? Are you alive?
I'm here and I'm alive, and this book is probably gonna be very different from the previous two.
Yeah, this is gonna be very different. This is more the type of books that I think we like more because these they go in a more of the philosophy of things, which I think we are more interested in.
Yeah.
So, Patterns of Software. This book, let I for the first time ever probably, I am ahead of Marinho.
I
Uh,
mean, if I knew you meant 33 of the book instead of the PDF, I would have read it because I really enjoyed reading the first.
yeah, it's
Uh,
really good. Yeah. Well, you can finish, but I agree.
yeah, there's some confusion about the page numbers because PDF pages versus book pages.
Yeah,
That's always a concern.
the reason I said 33 is because of this of the what's the name? The summary. Is that the name? No, the contents. 33 was here.
Okay, it's the first three chapters. I see.
Yeah, and
Abstract.
I didn't read this actually. I th I think this is not correct now because the quality without a name is on page 32, and this has more than one page.
Huh.
The
Let me
only other,
check that as well.
yeah. So I read these three. I read these three. We're only gonna talk about these two today because of the miscommunication. That's my fault. But it's plenty because I have so many things to talk about. Anyway, so the first thing, we're not gonna talk about this one, but the foreword of this book is really good. I think it was a Chad move to ask one of your inspirations to write the foreword of your book because Gabriel, which well, Gabe, by the way, the author of this book is Richard P. Gabriel, the author of the famous "Worse is Better" article.
I think he's also the guy who wrote about the bipolar Lisp programmer.
I don't know that one yet, but cool. This was Mageta's recommendation.
Uh, oh
Uh,
no, I messed that up. Actually, let me double check that actually, because now it's bugging me.
Sure. So Christopher, I think Christopher Alexander. Yeah. So he uses quotes from this guy a lot. He's apparently an architect and Huber, building critique. I don't know how to call it. And he has very interesting
Oh,
takes, although I have my problems with some of them.
okay. So just for the record, the bipolar Lisp programmer is by Mark Tarver. That's the Shen guy, not Richard Graybill.
Yeah, that's cool. So let's also jump the preface, but basically what we're going to talk about. So Gabriel is a critic who's going to make criticisms. He already beforehand mentions here that he's not going to propose solutions necessarily. He's just going to point out the problems, which is fine because he does a very good job at it. But I would say it's kind of problematic because if you propose problems that I have counter arguments and you don't have a proposed solution, what are we going to do about it? So that's one thing. The second thing is that his main focus is object-oriented programming. That's his main focus. So this book is not well. Maybe was on like on the pinnacle of like object-oriented hotness or whatever. When I say that, I mean um, I think he's not. Well, what is your opinion, Marinho? Do you think he's talking about Java object-oriented or he's talking about Smalltalk object-oriented?
Uh,
It's kind of hard for me to tell.
he could be talking about common Lisp class object oriented as well. That's an option.
Let's go with that. Um, well, anyway, so this the and by the way, uh, um, this the way that he writes is very well. So we're gonna not do the same style as we did the category 3 book with like reading everything. It's just gonna be more like the first book, the list implementation book, in which we skim throughout the entire thing.
Yeah, this is not mathematics. We don't need to look at the details necessarily.
Well, he's gonna criticize mathematics, so we're gonna talk about it a little bit. Um, and these are just a bunch of essays, so they are interconnected with each other. They reference each other, but they you can clearly see that he wrote like he had like the bursts of creativity and then compiled the book out of those bursts. So first section of chapter 1, reuse versus compression. So opinions about it. Opinions about it.
Uh, I'm not sure. Like, I like the idea of this distinction, but I'm not sure if it actually makes sense as a distinction.
I have the same position as you, which is kind of surprising because Benet mentioned that for him this distinction is the perfect description of modern OOP. At the time when he said that, I haven't read it, so I didn't know what would be the distinction. And I agree with you that it's kind of hit and miss because it seems that there is something deep here. Like it has the feeling that we are about to witness greatness in such of like we have two terms now to talk about two different things. But the way that he goes about it, in the sense that he mentions that compression has a very particular problem of you most the time have to know the implementation details of what is hidden from you. He specifically talks about, well, he relates that to object-oriented stuff such as a method, right? But then my question for him was, why doesn't a macro suffer from that? Why doesn't a function suffer from that? Why are they fine and methods are not? So
Well, it's not so much that methods are not fine, it's more so that classes are not fine. In the same way that, like, okay, suppose you're writing Clojure and you have to write a big map, which is just like another map that already exists, but with a couple extra keys. You could copy the original map, which would be kind of annoying, or you could say, okay, assoc original map, extra keys, and there you go.
or you do a
This
merge, right?
yeah, merge is kind of like assoc in this context, but the point is, there's a difference between adding a little bit of stuff to something that's intrinsically a collection versus you have a function, it has an input and an output, and you just respect that interface. You don't have to care about what's inside of a function, whereas you very much care about what's in a collection, usually.
Yeah, but his argument specifically, well, the introduction of this section is mostly about explanation of why reuse is important. This is not discovery. We're, this is not new. Everyone that does software knows that we praise a lot of reuse in our stuff. It is a hot topic as he's gonna go. Well, I guess next session we're gonna talk about abstraction, and there's a lot of entanglement between abstraction, reuse, compression, and the next section, which is the habitability, I guess. Um there, these four things are intertwined. They are very close to each other, and well, we're gonna talk about it. But anyway, he goes talking about that's important. He talks also about the act. Well, he makes a bunch of parallels. This book is full of parallels with everything. So in this case, is the act of you need to. The problems with reuse is that there is a barrier of entry, right? You need to know where to find the stuff. You need to know. We need to have documentation on what it does, and all of these costs. Sometimes this cost is so big that it's actually better for you to implement it yourself again. So he touches on that subject.
There's also the cost. I don't think he discusses this here, but there's also the cost of just pulling in a dependency, right? Because if you're going to reuse a library, well, now that's a dependency you have to care about. There's that as well. But that's more of a okay, we already have a library. Here's an issue that we now run into, right? That's different from saying, okay, I'm going to write software. How do I how can I make it so I can reuse this later, right? Those are kind of that's kind of a related but not quite the same concern that he's talking about.
Hmm. Hmm.
Um,
Okay, so here is the claim, right? In object-oriented languages, when writing a single program, a programmer uses code already developed by inheriting that code from more general objects or classes, right? So again, he's tying the problem of reuse very specifically to OOP and inheritance.
yeah, this is definitely a more Java-like notion of OOP, I guess.
Exactly. Yeah, that's or well, maybe the common Lisp OOP can also suffer from this.
Not really, because the way you abstract, like in common Lisp, methods don't actually belong to classes; they belong to generic functions.
Fair enough. So now we go to the main entry of this section, which is the notion that all these object-oriented languages, instead of using doing reuse, there is a better, allegedly, a better word to describe it, which is compression. So compression is the characteristic of a piece of text that, and by the way, I feel that he should have done the same treatment that he did for compression for reuse. Because as we already stated, we are not really buying this distinction. And I think that if he wanted to make a stronger argument, a stronger case for this distinction, he should have done this exact treatment that he did for compression. Reuse is blah 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 blah, and compression is the characteristic of a piece of text that the meaning of any part of it is larger than the piece has by itself.
Yeah,
Because this is a very specific definition, but we don't have the other side to do a contrast.
yeah, we don't have the counterparts that we're comparing it to.
So it's kind of, I think he kind of assumed that we're going to use the common sense definition. Although he could argue that this definition of compression is also common sense. If you ever study compression, it's very one of the possible strategies that you can use is to actually depend on your surroundings to compress yourself. That's a very common approach. That's like class one, like lecture one of compression. So this is not really something new, but I still hold the argument that this should have a counterpart contrast, because otherwise we're just with our common sense, uh, which by the way fits this description. You can say that fits the description in some regard, not completely, right? Not every single case of reuse is the characteristic of a piece of text that the meaning of it is part of a larger than the piece of itself. But you can make the argument that if you're calling a function in another function, the function body is not there.
You could, yes.
So you, that is saying that the meaning of it is larger than the function you're writing, because you're calling another one. So great start, but then he goes further. Then he goes further. There is an example, which is my horse was hungry, so I filled a morvet with oats and put it on him to eat, which is basically saying that you can deduce, even though you don't know what this is, maybe, you can deduce by the surrounding context what this is supposed to be. Sorry. So, which is a
Pronouns work
feedback.
because of compression. That's an observation that I never made, but yeah, that's totally true, actually.
Yeah, this guy has a lot of those observations. Like, You may not agree with his final takes, but the observations leading to it, they are great. Uh, so here's an example. If you make a subclass of a class which adds one instance variable and two methods for it, the expression of that new class will be simply the new variable, two methods, and a reference to the existing class. Again, I could make the same argument for a macro or a function. The new function is the call of the other one plus one, right?
Yep.
Uh, to some, the programmer writing this subclass is reusing the code in the superclass. But a better way to look at it is that the programmer is writing a compressed definition, the book of whose details are taken from the context in which the superclass already exists. And then, again, as I read this, I tried very hard to see where are we excluding functions and macros. Why is this? What in this is specifically tied to the objects and classes and methods? Um, so compressed code has an interesting property. The more you write, the further down the class hierarchy you go. The more compressed the new code becomes. So adding new code is very compactly done. For developer manager, this can mean that a new code can be written more quickly, which is, well, that's very fair to say.
It is true.
And then we go to the problems, right? So compression has clear disadvantages. Let's go through them. It is a little dangerous, apparently, because it requires the programmer to understand a fair amount about the context from which the compressed code will take its meaning. So basically, you're saying that I there is something that I'm gonna call from the superclass in the subclass, but instead of just having an assumption, which is gonna criticize in the abstraction chapter, by the way, instead of having an assumption based on its name, on the arguments of it, we're gonna make the argument that you need to go there and read it in order to make sense out of it. So not only does this require the available source code or excellent documentation, but the nature of inherent language also forces the programmer to understand the source or documentation. If a programmer needs a lot of context to understand the program he needs to expand, he may take a mistake because of his misunderstandings.
I
Which
mean,
is true regardless of the argument, right? Because like if you have an assumption based on the name of the function or method and its arguments, regardless of you need to read it or just use it as a black box, you may fall into this.
yeah, this is basically true whenever you use something by reference instead of inlining it, right?
Exactly. Um, and then maintaining, if assuming the premise, which is that you have to go there every time, maintaining complex code requires understanding its context, which can be difficult to maintain. The primary feature or ease of maintenance is locality. Locality is the characteristic of source code that enables a programmer to understand the source by looking at only a small portion of it.
Uh, I think this actually is a point where uh, if you're working specifically with pure functions, you have a small advantage here because like if you're dealing with mutable objects, arbitrary procedures that can do side effects, then that actually has pretty bad locality because you have to understand the side effects or the mutations that can happen and so on. If you have a pure function, you only care about the input and the output, right?
Yeah, but even assuming so, because when you talk about mutation, we the mutability adds to the mental model of programming, the act that your surroundings outside of the code matters.
Yeah, that's a form of non-locality.
Exactly, but his definition of locality is not that, which is a little weird to me. His definition of locality talks about the portion of the code you need to look at. So he's not necessarily talking about the network failed. He's not talking that we went offline for a reason, someone blew up something, which we are the things that we are talking about. He
I
is talking
mean,
about the amount of it.
well, yes, like if you have a subclass that inherits from a superclass and that superclass has a mutable field, you may look at just the subclass and say, okay, this doesn't mutate anything. This is pure, but it's
But
actually
that's the
not.
thing. But that's the thing, Marino. What you just described probably is not a lot of code. The mutability is a problem, regardless of how many lines it is being described with. Here, the locality is being bound is bind to the amount of code, the source code you are looking at. So if you have a gigantic piece of code that is immutable, for him is good locality. No, sorry, the opposite. If it's mutable, immutable, but a large piece of a large portion, it's not good locality. You see the difference.
Hmm.
Which again, it's weird. Like I never heard any definition of locality that talks about how the portion of the source code. So I don't
E-
know. I don't know.
e-
I don't know about that.
yeah, no. A better definition would have been to say, okay, locality is not really about the size of the code necessarily. It's about needing to understand extra context. I think that would have been a better definition.
Yeah, because here's how I understand it. Locality is about the distance between where you are at and the places in which can affect you. The further the delta, the worse locality it has.
Well, I would have talked about it in terms of quadrants because distances are problematic, but that's not a discussion for here.
Sure. Um,
But
but
yeah, I
anyway,
agree. If you're looking at a piece of code and a change very far away can affect the code that you're looking at, yeah, that's poor locality by any sensible definition of
but yeah,
locality.
but here's the catch. My definition doesn't matter if you're farther away and you are one line, or if you're farther away and you are a big chunk. I don't care. He cares. So unusual to say the least. But anyway, compressed code doesn't have this property that we're just the locality property. Well, which is true in this regard because objects in his context can be mutable. So again, for us, locality has a different semantics on what
Even
he's
if
talking
they
about.
were immutable, you still have to go to another definition to have the complete picture of a subclass, right?
Well, but now it depends because if they are immutable and I have one function call to go, is that good locality or bad locality? How many function calls determines how good the locality is?
I'm not talking about function calls, I'm talking about the actual definition of the subclass. Like if you have a superclass and it's defined in one place, the subclass could in principle be anywhere, right?
Yes, yes. Okay, I see what you mean. It could be anywhere. Like you actually can have like multiple superclasses, right? So like the base superclass that you may be interested in can be 50 files away
Yeah.
potentially. Yeah, I can see. I can see. Yeah, and your example also doesn't. So maybe that's what he's talking about code portion then. Maybe he's counting how many go tos you have to go as adding code.
Hmm.
Maybe. Compression has another obvious problem though. If you build derived code that tightly depends on some base code, then changing the base code can be expensive and dangerous. Which again, how this doesn't apply to functions? Because if you are using a function and I and you have something and you use my function and I change the function and you update your stuff, my base code function was changed. If the developer of the base code is not the same person as the developer of derived code, the derived code can be in jeopardy. This is just the problem of all by-reference relationships. This gets worse with by-reference because mutability is bad, right? We all know that. But I
But
don't
it's not
see.
even it's
Yeah,
not even just about mutability in this case. It's about okay, This thing depends on another thing that you're just calling by name, like the name of a function, the name of another class, the name of whatever, right?
Well, yes. Oh, you mean by reference? Here he's just talking about like labels. He's not talking about by reference pointers.
Although pointers do have this problem, so you know.
So compression in poetry is fine because the ultimate definitions of words and phrases are outside of the poet's mind. So this is a very important take that I'm going to use later for the habitability. Why poetry has the luxury of having definitions of words outside of the programmer, and the programmer in programming doesn't have the luxury. That's going to matter later. So the meaning of words, the classes are well. Here he tries to justify it, saying, not for the compression in programs. The meanings of the words, the classes, are determined by the programmer. So there are a couple of things, such as a class, that are not. They don't. Their definition don't live outside of the program. They live inside the program. However, not everything works like that, and I'm going to talk about that later. These problems are unique to class-based components, but applies to any abstraction-based compression. I don't want to imply compression is bad. Well, he's gonna say this multiple times, both here and for the abstraction. Um, and compression doesn't help inter-project reuse because to do so requires exporting classes that can be reused. This simply lends us to the classic reuse situation that we had earlier about having barriers of entry, which is a process problem and not a technology one, which is true. Uh, so then we go back to the development manager that would hire a developer over someone that its sole job is to do the reuse. And why that's the case? First is because reuse is the easiest within the project instead of between them.
Yeah, that goes back to the issue of okay, you want to reuse code that lives in a library. Okay, now you have to depend on the library. That's not free, right? You have to track versions, do package management and whatnot, right?
Well, I guess it depends because having a library being solely like depending solely on a library being hosted somewhere else, that's a potential risk, of course. But let's assume that you're using some sort of environment like I don't know, maybe the JVM, in which you can actually just leverage the .jars instead of
But you
leveraging the
still
GitHub repo of the thing.
but you still have the same problem, right? Because the you have to get the jar somehow.
Well, but that's not a problem anymore. If I download the jar and self-hosted myself, what's the problem? The problem becomes when I have to depend on a third party, which is usually the case because you don't want to maintain something else. That's extra cost.
The problem of just downloading the jar and hosting a copy of it is that okay, what happens if there's a bug and there's a new version? What now?
Well, that's what I just said. We don't do that because of two reasons. First, we don't want the extra maintenance cost of a library. We want someone else to take care of it, someone else to fix the bugs. And second, we want the updates. We like we basically want the updates for free. We don't, as I said before, we don't want the extra cost because if there is a bug inside, we somebody can fix it for us and we can just use a new version. But there's a trade-off there. If you want those two things, you want to accept the dependency on the third party. But if you are willing to just like I don't know do Zozin style and just download the C files in STB style header only libraries, you don't have to. You can just download the source code and use it yourself. The problem with that approach is that now you have to maintain it yourself. So
There's a cost either way.
there is a cost either way. Um, so well, you're gonna hire a developer for sure. So a project success often depends partially on the performance of the code. Uh, uh, well, basically, there are situations in which reuse is not going to help. So maybe investing on an expert for reuse is not worthwhile. And then the summary: the reuse is properly a process issue, which is mostly true. The individual organization needs to decide whether they believe in its long-term benefits. Objective-oriented languages provide compression, which in his case is putting as a replacement for reuse.
But only within a single program.
Uh, which can substitute for reuse within a program. He didn't say a single program, but there is a program, so I'm guessing single. And compression is not reuse, although I don't really buy that because all of the other because I don't have a reuse is I'm having to guess, and in my understanding, functions and macros would be classified as reuse, but they suffer from the same problems that compression suffers from. So, and both reuse and compression have their costs and savings. So, uh, I don't know. This first section, it's fine. I don't really agree with this conclusion of the compression. It seems to you that you didn't buy it as well.
Yeah, we would need a proper definition of okay, what do you mean by reuse specifically, right?
Yes, like I said before, I think this would have been way easier if he did the same treatment for reuse that he did for compression. Because this definition without another definition to compare is also fits the some use cases of reuse. But you said that your conclusion says they are different. So I don't know. Maybe you can ask Benny later about it. Okay, next section, which is going to be the last one for today. We are on the third and a half an hour mark, by the way, so we still have plenty of time.
Yeah, keep in mind I haven't read this because
No, you read this. This is 25.
this is 25. It is. I must have done something wrong when I was reading the book because
Oh, you haven't read the habitability.
uh okay, this is yeah, you are right. This is actually 25. Can I can't believe I did that.
Well, we can finish for today. Like we had great insight. I like the discussion anyway.
Uh,
Uh,
I'm willing to keep going even though I haven't seen this yet.
no, but it's hard. Like, uh, how can I put this? Well, we can try and see what happens. But the problem is that because you don't have the cached this,
Mm.
you are either gonna believe me as a source of truth, which should not be the case because I'm not the author, or we're gonna have to reread it right now.
Uh wow, I can read it. This is okay, it's talking about language design apparently.
Yeah,
That's
his main
something
point.
I
Yeah,
yeah, that's something I know something about. So
yeah, yeah. This is a very, how can I say? It's kinda the orchestra and jazz argument of Lisp again, but it's worse because I don't agree with what he's talking about. Because here's the summary of this chapter, okay? The summary is that there is a problem, which is that a perfect program in this author's mind is a program that fulfills its job perfectly, but it's static, which means that after the requirements change or we discover that we were wrong, we're gonna have a hard time, like this is gonna just crumble down the entire thing. So what he's actually talking about is that a program needs to be flexible. A program needs to be flexible, which in his he puts it in a way that makes it a dilemma. You if you go for correctness and being perfect and beautiful, you're gonna have to trade the flexibility. There is no way around that. But you want both requirements. But what he's proposing is that the flexibility is way better. So well, we can try to go about this. It's only 8 pages. Maybe we're gonna make it. So the first thing uh, is that the people are who does programming? People do programming, and which means that the concerns of the people should be our concerns as well. Uh,
which is fair.
which is fair, but there is a problem with the conclusion. I'm gonna get there. If the manager, well, there is an implication that he's gonna argue that I have a problem with. So then he goes about someone talking about the C++. So C++ is a general purpose programming language designed to make programming more enjoyable for the serious programmer. That's the quote. Then he goes with a better one uh, that again talks about C++. The important part is that C++ types and data hiding features rely on compile time analysis of programs to prevent accidental corruption of data. They can, however, be used freely without incurring runtime or space overheads. So why are those quotes here? Because the first um, insight is that these guys are talking about programming being enjoyable from an efficiency perspective. From an efficiency perspective, which right now, currently, that's not really what we care because computers now are fast enough. So now we have the luxury of not really going from the most pinnacle of efficiency because now the computers are fast enough, which in his case was not the case during his time. So he brings this efficiency argument many times, this performance thing. And the reason is, my understanding is that the reasoning behind that was because at the time that was a big deal. But then we go to a different definition of enjoyable, which is the one that Tennant proposes. A programming language is a system of notation for describing computations. A useful programming language must therefore be suited for both describing, for human writers and readers of programs, and for computation, for efficient implementation on computers. But human beings and computers are so different that it is difficult to find notational devices that are well suited to the capabilities of both. Languages that favors humans are termed high level, and those oriented to machines are coined as low ones. And then he goes to describe machine language as the most powerful low-level language, but he tellingly remarks, and this is where my disagreement with the author starts. It might be thought that natural languages would be at the other extreme, but in most fields of science and technology, the formalized notions of mathematics and logic have proved to be indispensable for precise formulations of concepts and principles, and for effective reasoning. So he then goes, precise formulation and effective reasoning, again, not exactly what I had in mind. Well, then he goes to Modular 3, which then says, Modular 3 is a modern general-purpose language, provides excellent support for large, reliable, and maintainable applications. The nature of programming has changed. For many years, we were puzzle solvers, focused on turning algorithms into sets of instructions to be followed by a computer. We enjoyed solving these puzzles, and we often viewed both the complexity of the puzzle and the obscurity of the solution as evidence of our skill. Aware of our human limitations, we have come to view complexity and obscurity as faults, not challenges. Now we write programs to be read by people, not computers. So this quote is basically to show a changing perspective. So before, on the old times, on the beginning of times maybe, we saw that the complexity of puzzle, the ability to solve complex puzzles, and the identifying the obscurity of its solution, that was a sign and evidence and a piece of evidence of skill. Now we see complexity and obscurity as mostly faults and not complex and not challenges, which it's kind of true because if you think about it, we don't have to we don't have to have deep brainstorms ourselves to in order to make a solution faster in O log n anymore, because the solutions that people did before, they are already fast enough with the current hardware. Because one of the things that pushes innovation and pushes new things are the limitations. If you have less limitations, which is our case, you have a less of incentive to find groundbreaking algorithms and groundbreaking new ways of doing things, because you can be comfort. The comfort zone got enlarged given that the hardware now is more powerful.
Uh, I wish this was true, that people see complexity and obscurity as faults, because if this was true, we wouldn't have to deal with microservices.
That's that is very true. And then this quote actually doesn't end, it finishes here. There is a pleasure in creating well-written, understandable programs. There is a satisfaction in finding a program structure that tames the complexity of an application. We enjoy seeing algorithms expressed clearly and persuasively. We also profit from our clearly written programs, for they are much more likely to be correct and maintainable than obscure ones. So he says that this quote is better than the Tenet one, which, by the way, this quote talks about formalization. It talks about precision. This other one, on the other hand, talks about the shift mentality that we had from puzzle solvers and obscurity discoverers to uh, people avoiding
Clarity,
complexity and obscurity.
yeah, clarity of communication essentially,
Yes.
except applying it to programming.
And then he says that it is better than the precise formulation goal that Tenet advocates, which is what I'm going to criticize because I still think Tenet is correct, and it is different league from the efficiency one. So we had three ones in comparison: precision and formalism, efficiency, and uh, clear clear
Clarity.
clarity, right? Actually, not clarity, because he's going to say that clarity and habitability are different. That's actually a good thing that you mentioned that, because it's going to specifically say that habitability and clarity are not the same thing. So then he goes to say that a characteristic of software that perhaps is not thought of, and which perhaps should have some influence in our in design programming languages, is habitability, which is the characteristic of source code that enables programmers, coders, bug fixers, and people coming to the code later in its life to understand its construction and intentions and to change it comfortably and confidently. Either there is more to habitability than clarity, or the two characteristics are different. Let me talk a little bit more. So then now we're going to talk about what he means about habitability, which, well, we have a definition, which is that, which kind of, I don't see the difference between this and familiarity. I kind of read those two terms interchangeably.
I don't think they are quite interchangeable because there's a difference between I know this code base very intimately and therefore I know where everything is versus I may not know this code base particularly intimately, perhaps because I've been away from it for a long time, but things are generally in the places I expect them to be.
Yeah, but how do you build your expectations? You only build
That
them with things that you are familiar with.
well, you may be familiar with other programs, not necessarily this one.
No, but we're not talking about specifically about a program that is so tied up and so coupled with a business domain. If you go to the code, and if I show you a code that, I don't know, it's there's nothing that you ever seen about that domain before. So you don't know what the terms means. You don't know you don't know what is the math that I'm doing there means. But you can read it, like in the sense that you already have identified, okay, this is definitely a macro, this is definitely a function, this is definitely an object, right?
Those are just syntactic elements. I don't think this is really about that.
Well, how can you approach a code later? You have to read it. You cannot ignore the syntax. Like, if you're not talking about the concrete act of reading, what are we talking about then? And by the way, this my explanation doesn't limit itself to syntax, because you may not know the syntax, but if you discover in 5 seconds using Google that it is an object, you have an abstract notion of what an object is, regardless of the syntax. So even if you don't know the syntax, you can very quickly understand what is this fragment of code supposed to mean, and you may find a word for it, such as a function, a macro, an object, regardless of the syntax of it. and you have already preconceptions because you are familiar with these concepts before. That's why to me habitability and familiarity, I kind of use them interchangeably, because in order for me to understand when you say object, I need to be familiar with at least with the idea of an object. So that's my defense. Uh, then we have another Christopher Alexander quote, which is organic order, the kind of order that is achieved when there is a perfect balance between the needs of the parts and the needs of the whole. This quote is very important. We're going to talk more about it later. Uh, so then, okay, so he talks about the specific building because he wants to give you an example of what is habitability in concrete terms. So buildings like the Superdome lack habitability. In this instance, people inhabit the building, but only for a very short periods of time and for very special occasions. And such buildings are not easily grown unaltered. The Superdome is an static building. Okay, so pay attention to this. Uh, he like there is the habitability notion has some sort of crystallization notion in the sense that if there is a lack of flexibility, then it implies that it is static. So then he goes another example. A modern skyscraper, to take another example, has a fixed inflexible interior, which is secondary to the design building of the exterior. Little attention is paid to the natural light, and often the interiors are constructed as cubicles, right? And these cubicles are not designed with the employees in mind, right? They are designed with the company in mind. How can I put the most amount of people in a productive way in the same space? And then he goes to the opposite side, what he classifies as has abundant habitability, which is a farmhouse. So in his example, as the family grows, the the
That, that,
exterior physical location also evolves.
that's a based example, by the way.
Well, I don't think this is exclusive to farms, but I knew you would mention that. So as a family grows and needs to of the farm grow, a back room is added to the house, then a cunning room, then a room for the grandma. Stables are added to the barn, then a wing for milking more cows. So like he's talking about the act of extensions and how the easiness of adding those extensions. Uh, so the result is rambling, but each part is well suited to its needs. Each part fits well with the others, and the result is beautiful because it's a living structure with living people inside. So what he wants basically is that habitability being a metric that tells us how how quickly and good can the can this mutate alongside me, the one that is using it. So
Hmm.
I am a living person, and it would be great if my house is also a living thing. So like, it sounds great. There is a problem, but it sounds great, right? So the inhabitants are able to modify the environment because each part is built according to familiar patterns of design, use, and construction, and because those patterns contain the seeds for piecemeal growth. And this is another keyword, key expression. He's going to use this a lot in the abstraction as well. Piecemeal growth. And then he says that we may consider this for computer science. And then he goes with, again, I don't really agree with, which is most programming languages are excellent for building the program that is a monument to design ingenuity. Pleasantly efficient, precise, and clear. But people don't build programs like that. Programs live and grow, and their inhabitants, the programmers, need to work with the program that the way the farmer works with the homestead.
By the way, this is a stealth jab at Python because it's neither efficient nor clear.
Of course it is. Of course it is. So then he's basically saying that programming, the actual mystery that we need to solve in the next generation is whatever we define programming to be. It is not about issues of elegance and monumental programs. So like to him, there is a mutual exclusion process, which is that Things that has a quote static structure, they are crystallized, they are very solid, they are very unflexible. And because the programs need to change, not only because of the requirements, but because of us, hence, we need to make that trade. We cannot afford having the elegance of monumental programs.
I don't think crystallized was a good choice of word here, Lemus.
I think it is because a
Bec-
crystal is very has a very defined and fixed molecular structure.
but it can grow.
Well, it can grow, but it's not that's not the growth that he's talking about. He's talking about growth that does this, like the molecules are not you're not adding more, because if you're adding more, this is a skyscraper, right? Where is the skyscraper example again? Here it is. When you
But you,
run out of space in the skyscraper, you build another one.
well, you can grow a crystal.
Yeah, exactly. But this would be the parallel with adding another skyscraper.
No, 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 no. You can take a crystal as a seed and actually grow it.
Yeah, you have another skyscraper. You have more crystals. You are not changing the crystal with the internal the existing crystal to make it more space. You are just adding more. It's exactly the skyscraper example. What he wants is flexibility in this analogy, the flexibility in terms of the molecules. Like the structure is so loose that you can actually break it apart. That's what he wants. Which is very jazz argument, right? This is very jazz argument of Hickey. But then it comes to this conclusion that in this way of describing it, the elegance of monumental programs is being traded for this peace growth, flexible way of doing things. But I haven't reached my criticism. So let's continue. So overuse of okay. So what are the some of the things that contribute against that goal? Because we want to make habitable programs. Overuse of abstraction, inappropriate compression. But that's topic for another day. In Alexander's definition of organic order applied to software, the concept of needs of the whole refers to the grand design or architecture of the piece of software under development, and the needs of the parts refers to the inevitable changes that various parts of software undergo. It's difficult to change the grand design of software. You cannot expect to evolve a Windows system into a spreadsheet.
Well, I
Although that
mean,
okay, go.
you could argue that people use Excel to go the other way, so,
Yeah. Although the primary need of the whole is to remain true to its essence, the parts often must change. For instance, one sort of Windows system could evolve into another. Then, software needs to be habitable because it always has to change. Software is subject to unpredictable events, requirements, competitors. We were wrong, and people learn to use software in ways not anticipated. Notice that frequently the unpredictable event is about people and society rather than about technical issues. So again, his proposal is that habitability is about how fast the tech can keep up with us. Such unpredictable events lead to the needs of the parts which must be comfortably understood so they can be comfortably changed. Then he goes about talking about bugs, right? So bugs may not be the result of a mistake, but bugs for Gabriel, they are evidence that you cannot make a master plan. Because if bugs are not always mistakes, they can just be uh, not correct because of another reason. And then
maybe you never considered a use case,
a
but
corner
then people
case.
went, yeah, maybe you never considered a particular use case or a corner case, and people find out about that, and then it's like it surfaces, I guess.
Exactly. So a master plan is detailed design, and many projects consider critical that detailed designs. But a master plan is not usually possible, especially not extensive, long-lived software. And then he says, with Alexander quoting again, it is simply not possible to fix today with what the environment should be, and then to steer the piecemeal process of development that fixed imaginary world. So this is my I have two critiques. So I have one critique so far. This is my second one. Again, the master plan idea is being glued to the idea of static, unmovable.
It's yeah, it's like there's a there's a I'm not sure if I would call it a conflation necessarily, but it's like he's assuming that you cannot plan to change, you know.
No, yeah, exactly. There is no meta master plan that gives you building blocks that are powerful enough that they give you flexibility that don't trade correctness. He assumes these two characteristics are mutually exclusive. If they are correct, they are stopped in time. It's a snapshot. Once the environment changes, once the requirement changes, that snapshot is not useful anymore. And he goes further. There is another argument which I also disagree, which is that master plans have two additional unhealthy characteristics, which is Alexander again. To begin with, the existence of a master plan alienates the users. And users in these cases are the programmers. After all, the very existence of a master plan means, by definition, that the members of the community can have little impact on the future shape of their community, because most of the important decisions have already been made. So what is being said here? It's being said that because a master plan has already been established, there's no usefulness of people contributing to it. Because you didn't participate in the decision making process of reaching that conclusion, you're going to feel bad about it. That's the argument. And in a sense, under a master plan, people are living with a frozen future, able to affect only relatively trivial details. When people lose their sense of responsibility for the environment they live in and realize that they are merely cogs in someone else's machine, how can they feel any sense of identification with the community or any sense of purpose? Second, neither the users nor the key decision makers can visualize the actual implications of the master plan. There are another two bold claims here. Uh, Not participating on the decision making process not only makes you feel not great by yourself because you haven't participated in the decision after all, but you also feel like you're being used by someone else. You are only a tiny little piece in someone else's machine. And there is another plus, or at least in this case a minus. You are gonna lack the sense of responsibility. And then finally, there is an oversight claim that the creators of the master plan, the people that made those decisions, they are incapable of visualizing the actual implications of that. Some parts of that claim is undeniable because if the requirements change, the plan that was crafted for a specific purpose now may have flaws.
The second point reminds me of Hayek.
Which part? The responsibility one?
No, no, the part about implications of the master
Yes,
plan.
yes, that's exactly Hayek's argument, right? Which, like I said, this one is not entirely insane because, yes, if you make a plan with a list of requirements and the list changed, there is a very solid chance that the plan will not work, at least in its full capacity. Everything else, to me, is just insane. To say that because I didn't participate in the decision making process, it is an automatic guarantee that this is going to affect my sense of responsibility. I'm going to feel used by someone else's machine being a cog. I don't understand this reasoning because if a decision was made without my participation and I am now being included in that process and it's explained to me why that decision was made and I agree, how can I not feel good about it? It's almost like an ego argument. I want to have the praise that I participated in the decision. I care more about that than by helping a cause that I agree with.
Hmm.
It's I don't understand. Like you can participate in something that you didn't participate in its inception if you see sense in it. A lot. That's how everything works most of the time. Aside from the very specific instance in which you are the lead engineer of something and you have the authoritarian power to say yes or no, you are participating in someone else's idea. You are participating as a cog of the machine. But how can that be bad if you see reason in it? So, like, this is gonna come back later on again as like how do the programmers feel about it? And like they feel used, they lack the sense of responsibility because they were not there. And I don't buy it. I just don't understand. So this is one of my critiques. Uh, let's continue. Well, if you have comments, Marinho, please share. I don't know if you're thinking about it or I'm just not allowing you to say anything.
I'm thinking about it.
Okay. Uh, okay. So uh, several points come to mind. First, when you design software, let the implementers complete those parts of the design for which they are responsible. So again, it's not allowed. Apparently, it's a bad thing to maintain something that was designed by someone else's. You need to allow the implementers complete those parts of the design that they're gonna be responsible for. So have you ever and then it comes up a human problem, which is that who owns this, right? Because if they lack the sense of responsibility, this question becomes a problem. It's because the manager knows that the excellent employee needs to feel he or she has some authority over what they are responsible for. Further, a well-knit group has this same sense of ownership over what they work on, plus a bond of elitism that holds them together and makes each member of the team feel responsible for the other's success. How can they feel responsible for the other's success if if someone else's did the inception of the design of the thing? It's not good that you're gonna be maintaining
Hmm.
it. How do you enable a programmer to feel responsible for software developed earlier? Right. Here's where habitability comes in. Just as with how, because I was criticizing Alexander's quote, which, by the way, could be just a snippet that was unfortunately snippet without the rest of the context, right? Maybe what I just explained, he was about to say, and Gabriel just cut it.
Well, that's the problem of compression, right?
That's the problem of compression. So, but he's trying to address one of my problems, right? So how do you enable a programmer to feel responsible for software developed early? Because that's kind of my point, right? You can feel responsible. And his argument is that this is where habitability comes in. Just as with a house, you don't have to have built or designed something to feel at home in it. Most people buy houses that have built or designed by someone else. These homes are habitable because they are designed for habitation by people, and people's needs are relatively similar. As I said earlier, the farmhouse is habitable, and the new owner just feels as comfortable changing or adapting that farmhouse as the first farmer was. So again, that's another reason that why familiarity. I think I use that interchangeably because he says things like this. But a home designed by this guy, though more habitable than over-designed homes, cannot be altered because of its parts are too rigid designed and built. The needs of the whole have overshadowed the needs of the parts and the needs of the inhabitants. And then finally, if the life applies to software, it implies the development project ought to have less of a plan in place than current thinking allows. So now we go to the argument that maybe software is being overplanned. It's not a lack of planning. It is not that the ideas that are being the foundation of the plans are wrong. It's the act of planning in excess. This provides a mechanism for motivation and a sense of responsibility to those developers who later must work with the code. Then he goes again with the principle of organic order. Planning and construction will be guided by a process which allows the whole to emerge gradually from local acts. Which, well, Hayek again, this is a very common thing. Um and then we go to each new building is not a finished thing. They are never torn down, never erased. Instead, they are always embellished, modified, reduced, enlarged, and improved. This attitude to the repair of the environment has been commonplace for thousands of years in traditional cultures. We may summarize this point of view behind this attitude on one phrase: piecemeal growth. So, uh, repair. This is another keyword as well. What gets in the way and prevents software habitability is over design, over abstraction, and the beautiful tout monument of software. Again, these two things are kind of being glued together. All of these things. So the over design problem, the over abstraction problem, they they are being glued here to the beautiful tout monument of software, and that's bad. And then
Mm,
Alexander calls this the large lump development, which this is described as a static and discontinuous environment. Piecemeal growth hinges on a view of the environment which is dynamic and continuous. According to the large lump view, each act of design or construction is an isolated event which creates an isolated building, a perfect building at a time, and then abandoned by its builders and designers forever because it doesn't serve anymore given the change of requirements. According to the piecemeal point of view, every environment is changing and growing all the time in order to keep its use in balance, and the quality of the environment is a kind of semi-stable equilibrium in the flux of time. Large lump development is based on the idea of replacement, and the piecemeal growth is based on the idea of repair. So again, very, very contrasty and polarized descriptions.
I have a feeling that this should relate to microservices somehow, but I'm not quite sure how.
This is exactly like you can 100% put the piecemeal growth argument as microservices. Because as you recall, the whole promise of the microservices architecture is to allow things to go down and up independently and only have the interface as the coupling mechanism.
I think that's backwards actually, Lemos.
Well,
Because like the basic idea of, well, the purported idea of a microservice is that, okay, you have this thing, it's responsible for its part of whatever business we're doing. It communicates with the other parts, but it's actually isolated from them, theoretically, right? Well,
no, but that's what I said.
but that's kind of like it's not really part of a whole. It's just its own thing, right? This would
No,
actually
it's no.
be.
The whole is the graph. It is its own thing, but the whole in this analogy of the microservices would be the entire graph and the connections via, well, synchronous or asynchronous connections between the services. Those will be the edges of the graph. Oh, you need a new responsibility. The previous service doesn't fit anymore. Just nuke that and create a new one. You don't have to nuke the entire graph. That's that's the argument there.
Mm, that's not quite because like the following paragraph makes me think that actually a monolith would be less like a large lump, which is a weird thing to say, but that's the impression I get.
Well, could you elaborate? How does a monolith not fit with the large lump development description?
Because if you have a monolith and the requirements change, you're not going to throw away the entire monolith because it's a big thing, right? You're going to adjust it or tweak it or fix it somehow.
Yeah, but wouldn't you agree that if you have a monolith, it's that there is high probability that the foundation of everything is a single centralized thing?
There is,
Like the
but
branches of the tree may be different, you can cut the branches, but the foundation, like another analogy on top of another analogy, the tree has the same. foundation.
Uh, the way I see it is that um, let's see, perfect. Like it's the way I see it is like the monolith. If we go back to the farmhouse example, the monolith would be like the ground beneath the buildings, I guess.
Ah, I see. So each individual new spot, such as the grandma's room, would be a branch, and the ground is the foundation.
Yeah.
I see. I see. I see.
Whereas with microservices, it's like, okay, you have these things, they're pretty isolated. There's no common foundation for all of them.
Yes.
Like, so like, it's kind of weird that large lump describes, like, if you think about it like that, then large lump is actually microservices.
Yes. If you think it like that, that's true. That's true. Recall that one of the tenets of encapsulation is that the interface be separate from the implementation because this permits the implementation to be replaced when needed. The problem with traditional approaches to abstraction and encapsulation is that they aim at complete information hiding. That's another hot take. This characteristic anticipates being able to eliminate programming from parts of the software development process, those parts contained within module boundaries. As we've seen though, the need to program is never eliminated because customization, modification, and maintenance are always required. That is, piecemeal growth. A better goal is to minimize or reduce the extent of programming, which implies providing mechanisms that allow small changes to larger already correct code. And I don't really understand this because there is no way to do complete information hiding, right? The least amount of knowledge that you can ever expose is always greater than zero. You are either exposing the function arguments, or you're exposing an endpoint, or you're exposing a topic. And those things have names, mind you. So how are you doing complete information hiding exactly?
Well, you're not exposing the body of the function.
Yeah, no,
You're not
I'm not saying you're exposing everything, but he says that the traditional approach to abstraction and encapsulations aim at zero. How come?
You could make the argument that a topic is an interface and that the function arguments and return value are an interface,
Yeah.
and that,
Are you not exposing that?
well, you're exposing the interface, but not the implementation, is the point.
No, he's not talking about implementation, he's talking about programming. Right. He's basically interpreting that there is a black box that is completely black, and the your aim is to make it as black, like purely black, right? My understanding is that at the moment that you provide an interface, it cannot be completely black. Am I wrong?
Hmm, I don't think you are, no.
So this goal of minimize or reduce the extent of programming is already the case. Maybe he's talking about like if you accumulate all the worst practices available, like the function names are worthless, the arguments they are also worthless, and they have worthless types. All of them is object, right? You don't have specific types. So if you have that situation, then I can kind of agree that you are aiming at complete information hiding. But who does that? Maybe I am looking too much into it. I don't know. So one of the primary reasons that abstraction is overloved is that a completed program full of right abstraction is perfectly beautiful. But there are very few completed programs because programs are written, maintained, bugs are fixed, features are added, performance is tuned, and the whole variety of changes are made both by the original and the new programming team members. Thus, the way a program looks in the end is not important because there is rarely an end, and if there is one, it isn't planned.
Some library authors may have a bone to pick with this.
No, again, this guy is full of hot takes, which is expected. He wrote fucking worse is better. I can agree with most of it aside from this part, that if an end is achieved that was not planned. But well, maybe I'm just looking at too many exceptions.
Like,
Uh,
if you have a piece of code that is correct with respect to a particular set of requirements, it is correct forever for that particular set of requirements.
but that's Alexander's criticism, because he says, where is it? Here it is. According to the large lump point of view, each act of design or construction is an isolated event, which creates an isolated building, perfect at the time of its construction.
No, but it's not perfect at the time of construction. It is perfect forever for that particular set of requirements.
Well, but that's a premise that they don't use, right? There is no static requirement list. The entire argument is that the piecemeal growth approach allows you to change alongside the requirements. Um, what is important is that it be easy for programmers to come up with speed with the code and be able to navigate through it effectively, to be able to understand what changes to make, to be able to make it safely and correctly. If the beauty of the code gets in the way, the program is then not well written. Just as an office building designed to win design awards is not well designed when the building later must undergo changes, but those changes are too hard to make. So the argument, the parallel that he's making here, is that beautiful code is rigid. And because
I
we cannot
disagree
afford
with.
it,
Yeah, I disagree with that.
yeah, well, I as well. But there is a deeper problem. A language is purely designed that doesn't recognize this fact, and worse still are those languages that aim for the beauty and elegance of the never finished program. So the argument is that you cannot finish the program because the goal is always changing. The requirement list is always changing, which means that the beautiful and elegant approach, because it's assumed to be static, it can never accomplish the goal because the goal will never be fixed. So again, think that over true. And then finally, this is the end, right? Yeah, this is the end. We are 17 minutes over, but I think it's very great. We are very close to the end. Habitability is not clarity. If it were, then modular theory will hit the nail on the head. Clarity is just too rare and too dangerous in a funny way. Books on writing tell you to be clear and simple, to use plain language. What can this mean? It is no advice at all because no one would ever try to be muddy and complex on purpose. To use obscure language as part of an honest attempt to be understood. So if you're trying to honestly be understood, you're gonna not use muddy and complex language or obscure language. But clarity is a quality that is rarely achieved. Rare because it's difficult to achieve. However, even though only the rare writer or poet throws off an occasional clear sentence or paragraph, many of us are able to be understood with little problem because our writing is habitable. Not great, but easy enough to read, easy enough to change. Yeah, this is what brought me my main criticism of this section. The danger of clarity is that it is uncompromised beauty, and it's real tough to improve uncompromised beauty. Many second and third rate sculptures can fix a decent sculpture. I saw a group of them one summer making replacement of, well, gargoyles for the Notre Dame
Gargoyles.
gargoyles for the Notre Dame Cathedral in Paris. But which of them would dare to repair Michelangelo's David? Who would add a skyscraper to the background of Mona Lisa? Who would edit Eliot's poems? Clarity is dangerous. If a programming language is optimized for the wrong thing, like pleasing efficiency, mathematical precision, or clarity, people might not be able to live with it or in it. It isn't inhabitable. Piecemeal growth isn't possible, and the programmers who must live in the software feel no
I
responsibility or ownership.
I think there's an assumption of mutability here that's like
It's the opposite.
weird.
It's the opposite, Marin. It's the Actually, that's an awesome way to finish this because you actually brought me the best expression to explain my criticism. The premise is that people are immutable, believe it or not. He's trying to argue that because people change and the best tool must change alongside us, the static nature of beauty cannot be achieved. But it's actually the opposite. It's because he's arguing that people are immutable, that the tools need to flex to match us. See what he's saying here? He's saying that uh, uh, it's very rare that a writer or poet throws off an occasional clear sentence or paragraph. Many of us are able to be understood with little problem because our writing is habitable. What if your habitable is bad? And what if your team members also have bad writing? You have scarce vocabulary. You have scarce ways of expressing yourself. If everyone around you is similar to that, the habitability depends on you guys, which means that if you guys are bad, good will be tough. It means that nobody will have the courage to do greatness because they may be bad. This entire thought process doesn't assume evolution of the people, because if they were evolving, how can you be so sure they will never achieve such greatness to have the courage to change these masterpieces? If they are improving and if they are adding more vocabulary and adding more writing skills, they are becoming better artists. How can you be so sure that they will feel that uncomfortable with such as a tough task to pull it off? The author is assuming that if you have something that is great but people don't know about it, you are the wrong because it's inedible for them. This is literally the legacy is the most important thing argument. Because the only way for something to be habitable is if people have an easy time with it. Everything that we just read points to the direction that if something doesn't feel at home to you, you are not the problem. The people that did before you were the problem. Even even if their master plan was a great plan. So let's suppose that there is a different technology that is allegedly better than whatever you happen to know and are familiar with. If you go and get hired for that company that has that different technology, Gabriel would rather say, bend that to your habitability's will instead of assessing that maybe you are about to touch greatness. And it, of course, is going to be inevitable in the beginning. That's what learning means. So my critique is that habitability is such a trap because if the people that are interacting only know JavaScript, of course, any Lisp or Haskell abstractions will be bad. Any of them.
I would have used Python as the example actually.
Like,
Because JavaScript, like, it is actually idiomatic to use higher order functions, at least.
no, okay. Regardless of the example, I think you see my point across, which is that this, what gave me this conclusion was these two paragraphs, man. Because he's literally saying that the writer, like, if Mageta, which has way better vocabulary than both of us, if Mageta uses an obscure word, he's being dishonest if he's trying to be understood. It is not us that lack the vocabulary to keep up with him. It is him that needs to keep up with us. There is no assessment of who is right on it, because he's basically assuming that what's most important are the people that's gonna maintain this, which are the current people. If the previous people made a decision that nobody in the current team can understand, he's already putting the blame on the previous people, which, if not done correctly, can be a huge problem. Of course, if you have a team that did a bunch of stuff and you fire all of them and you hire new people, there is a chance that the new people will not be able to understand completely what the heck is going on.
Hmm.
But if you do the process properly, which is you don't fire everyone, you fire most of them, and you keep the best ones to document the process to teach the new generation. That's how you can make sure that if what they did was if there was anything great in what the previous team did, the new team will be able to pick it up. So
Hmm.
that's my critique. Like uh, I wanted to reach this end because well, these two paragraphs are just a good way to do it. And my main critique is that what if the people that are assessing their habitability, what if they are not good? And I'm not even saying people outside. Let's say that I'm not good. If I'm maintaining a code that Marinho did, and it's not comfortable, it's not home for me. Am I the correct one and Marinho was the wrong? Why? There is a need to assess correctness because if Marinho made a more something that has a correctness as an invariant, and whatever I know is kind of flaky, is kind of imperfect, the only way to know who is on the wrong and who is on the right is to assess the correctness, which is it should be the goal of a master plan. A master plan that you maybe are willing to participate with other people. The master plan is supposed to make sure it's correct. But here, elegance, correctness, and beauty are being tied to static. So I cannot make that argument then.
It's like, yeah, it's like he's assuming that a master plan must know every single detail about everything, but like you
Including the
can make a
future.
including the future, but you can make a master plan, quote unquote, in which you say, okay, I know this, and this, so I will plan that to the most excruciating detail possible, and I don't know about that, so I will make provisions so that I can deal with what I don't know and can remain flexible, you know.
Yeah. Uh, well, we are already 1.5 hours. Well, 1 hour and 27 minutes. I talked a lot, but well, I was kind of excited to talk all about this because uh,
I'll
this
have
is
to
why the
think
book
more
is
about.
great. This is why the
Yeah,
book is
I'll have.
great.
Yeah, it's a book that actually makes you think and consider things that you may have not thought about before. Yeah, that's a good. I'll have to think more about this actually because yeah, this is interesting. I will say that.
This is interesting. That's all I have to say to the jury. This is interesting.
I
Uh,
mean, as far as I'm concerned, being interesting is good. So you
no,
know.
that's good. But I hope, like, you don't have to agree with anything I said. Read it yourself. Think more about it, and then we can have a separate
Hmm.
offline discussion. But my take on this is that habitability, of course, before everyone thinks I'm insane, I'm not saying that over abstraction is not a problem. I'm not saying that over bloated crap is not a problem. What I am saying, however, is that the implication that he's going for because of those facts, I have very serious problems with it. Especially because the analogy is that, uh, like, probably when he wrote this, he was thinking about that very hateful politician, probably, which is fair. But what if the obscure language is just because you are not good enough?
Ignorant.
Exactly. What if nobody has the balls to do any of this because they are not good enough? Which, to be fair with him, that's what makes clarity dangerous then. Because if you're not good enough, there is a high risk you're going to mess it up, which is fair. But what's blocking us from improving? We can acquire more vocabulary, we can be more skillful, we can improve our skills. So it's kind of ironic that he's talking about a future that always changes, and he's assuming that the people don't change. What they have is what they are is what they have. If they only know Python, that's it.
I would rather not work with anyone who only knows Python.
But that's my no. But that's not my problem. I don't have any problem with someone that only knows Python. I have a problem with someone that only knows Python and is not willing to know anything else. That's my problem. And to me, if the person is willing to learn more stuff, the
Yeah, that's
habitability is such a changing thing.
it's like if you go to another country where the culture is different, the buildings are different, the stuff you see when you're just walking about is different. Is that habitable? That's um that's an interesting question.
That is an interesting question for sure. Uh, well, I'm gonna finish the recording. Do you have anything else to say?
Yeah, this is interesting.
Yeah, no, this is very good. It doesn't matter if we both agree with the author, if you disagree with the three of us, the author, Marinho, and myself. It doesn't matter. What matters is that this type of writing, this type of looking at the subject, is was what intrigues me the most, because this is what makes me like it can feel that I'm trying to be contrarian because well I'm basically hitting it back. But that's not the case because there are a couple of things that I agree. I agree over abstraction is bad. I agree that over bloating is bad. I just have problems
Yeah,
with the conclusions of those facts.
yeah, please don't write abstract strategy factory factories. That's not a good idea.
Yes, exactly. Uh, um, but again, I think this is already a 10 out of 10 book. Just like we did 1.5 hours discussing philosophy essentially.
And Magetta is missing this,
Yeah,
unfortunately.
yeah. Well, but everyone needs to do what everyone needs to do. I'm gonna finish the recording now.
Bye, future people.